In this video, we discuss problem 6.4.6-T. The problem statement says the overhead reach distances of adult females are normally distributed with a mean of 195 centimeters and a standard deviation of 7.8 centimeters. In part A, we're asked to find the probability that an individual distance is greater than 205 centimeters. In B, we're asked to find the probability that the mean for 20 randomly selected distances is greater than 193.20 centimeters. And then in part C, we're asked, why can the normal distribution be used in part B, even though the sample size does not exceed 30? And then part A, they're asking us for the probability, and they're asking us to round to 4 decimal places as needed. In order to solve this problem, I'm going to share my paper with you. So we're right here. And they told us that the overhead reach distances of adult females are normally distributed with a mean of 195 centimeters and a standard deviation of 7.8 centimeters. So if I sketch a normal distribution for those overhead reach distances of adult females, in the middle we would have the mean of 195 centimeters. And then if we wanted, we could go out one standard deviation from the mean in each direction. So if I add the standard deviation to that, I get, it looks like 202.8 centimeters. That's one standard deviation above the mean. And then one standard deviation below the mean is that 195 minus 7.8. Which is approximately 187.2. That's the mean minus a standard deviation. Now we're asked to find the probability that an individual distance is greater than 205 centimeters. Now 205 centimeters is going to be somewhere over here. And we want the probability that the distance is greater than that. So what we really want is the area of this region right here in that right tail. Now, in order to find that area corresponding to an X value that is greater than 205 centimeters, well, we need to either use Excel to find this probability, or we can use table A2. Either one will work just fine. Now, both Excel and table A2 give us probabilities to the left, not to the right. So if I want the probability that X is greater than this value, then I will have to calculate 1 minus the probability that X is less than or equal to that value. And this can be found either in our table or in using Excel. In order to use my table, I would have to convert this X value to a corresponding Z-score. So I want that Z value right here. Now, here we're talking about an individual distance. So the conversion for Z-scores here is that we take the X value and we subtract the mean and we divide by that standard deviation. So we've got 205, we're subtracting the mean of 195 from that, and we're dividing by 7.8. So let's see, 205 minus 195 is going to be 10, and we're dividing by 7.8. And so we get about 1.28 standard deviations. And that makes intuitive sense because one standard deviation above the mean was 202.8 centimeters. And this is a little bit more than that, but it's not quite 7.8 distance or 7.8 centimeters more than that. So it's not at that 2 standard deviations above the mean. It's somewhere between 1 and 2, and it turns out to be 1.28 standard deviations above the mean. So I can use table A2 to find this probability, and then I'll subtract it from 1. In order to do that, I will share my screen with you. Now I'm looking for a z-score that's positive. So I go to my tables, go to positive z-scores, and I'm looking for z equals 1.28. I'm going to zoom in a little bit. 1.28, 1.2 is on this row, and then we have 1.20, 1.21, 1.22, 1.23, 1.24, 1.25, 1.26, 1.27, 1.28, and we have an area to the left. Remember, this table always gives us area to the left of approximately 8.997. So I have the area to the left is approximately 8.997, and this area is going to be 1 minus that area. And we get approximately 0.1003. And all of this is an approximation because we used that 2-digit approximation or 2 decimal place approximation for that z-score. Now, if we wanted to be more accurate, we could use the normal distribution function in Excel, and that would give us a better approximation of the probability that x is less than 205 when we're dealing with a distribution that has a mean of 195, a normal distribution with a mean of 195 and a standard deviation of 7.8. So we could do that, but I'm just going to use these approximations. Now, we were asked to round to 4 decimal places, so that is the answer rounded to 4 decimal places. Let's go back to the homework and see if it likes this answer. So you have 0.1003. Yep, my lab statistics likes it, so that's a good sign. Now for this next one, notice that this is a little bit different. Sorry. Here we are. We're asked to find the probability that the mean for 20 randomly selected distances is greater than 193.2 centimeters. Now we know that since the overhead reach distances of adult females were normally distributed, the sampling distribution of their means will also be normally distributed. So here, the mean of the sample means turns out to be exactly the same as the population mean. So the mean of the sample means is equal to 195 centimeters. And the the standard deviation of the sampling distribution for the sample means is not equal to the standard deviation for the original population. It's equal to the standard deviation for the original population divided by the square root of n, where n is the sample size. So in our case, the standard deviation for the means is given by that 7.8 centimeters divided by the square root of 20, which of course we could simplify, but we won't worry about that. Okay, so that is the mean and the standard deviation of the distribution of the sample means. Now the question is, okay, find what is the probability that the mean for 20 randomly selected distances is greater than 193.2. Now this mean of the sample means is 195. So this 193.2 is less than the mean. It's less than the mean of the sample means. So I would expect this to be associated with a z-score that is negative. Let's see what else it says. Find the probability that the mean for 20 randomly selected distances is greater than this value. Since I'm looking for the mean to be greater than that, I'm looking for this area to the right of that proposed sample mean of 193.2 centimeters. Now, in order to find that area, I need to convert this X bar to the corresponding Z-score. And the way we find that is we take the given X bar. I know the formulas in the tables say X minus the mean divided by this. But really, it's this particular value of the sample mean X bar. So I'm going to use that symbol instead. We're taking that particular value of 193.2 centimeters as a possible sample mean, and we're saying, what's the probability that the sample mean for those 20 randomly selected distances is going to be greater than 193.2? Well, in order to find that, I need the probability that Z is greater than the corresponding value, and that's because it's to the right, and our table A2 only gives us area to the left, and Excel only gives us area to the left. I'm actually going to take 1 minus the probability that Z is less than or equal to whatever that value is right there. Okay, to get the value for Z, that's what I was getting at over here. We're going to take this sample mean, that 193.2 that was proposed, and then we'll subtract the mean of the sample means, and we'll divide by the standard deviation of the sample means. Or alternatively, we're just going to take X bar, which is that 193.2, and we're subtracting the mean of the sample means, which happens to be the same as the population mean, that 195, and we'll divide by not the standard deviation of the population, but the standard deviation of the sample means, the population of sample means, which is given by this population standard deviation for the original population divided by the square root of the sample size. So we'll have the 7.8 here, and we're dividing by the square root of 20. Now you want to be really careful how you enter this into your calculator. If you do this in the wrong way, you're going to get the wrong answer. So what I would suggest is you do the numerator first. So I'm doing 193.2 minus 195. I get some answer. And then I'm dividing by open parentheses this fraction, 7.8 divided by the square root of 20. And that's what I have there. And then if you hit equals, you get that value. It's an exact answer, but we want an approximation, and we'll round to 2 decimal places. That's Z equals negative 1.03 approximately. So we want the probability that our Z-score is greater than negative 1.03, or alternatively, we want the probability that that sample mean is greater than this value, which means that that sample mean is more than 1.03 standard deviations above the mean. Now, in order to find this using table A2, I have to use the area to the left, not the area to the right. So I'm going to use table A2 to find this now. And since this is a negative Z-score, I'm going to use the negative Z-scores page of my table. So I'm here. This is the positive Z-scores page. Negative Z-scores are over here, and I want Z equals negative 1.03. So there's negative 1.0, that's going to be negative 1.00, that's the area to the left of that, negative 1.01, negative 1.02, and negative 1.03. So that area to the left is 0.1515. And we actually want the area to the right, so we'll take 1 minus that answer for our answer over here. Now this is an approximation. Well, actually, these guys are equal to each other. This is an approximation of this because this Z-score was rounded. These guys are equal, but then this is an approximation as well. So let's see what we get as that area to the right, 1 minus 0.1515, and we get approximately 0.8485. Okay, let's go back to our homework assignment. Oops. Trying to find that window. There it is. Okay, we're asked for that probability, and to 4 decimal places, that's 0.8485 if we're just using table A2. 485. Okay, answered that correctly. Good. Awesome. Fantastic, they say. Now the part C says, why can the normal distribution be used in part B even though the sample size does not exceed 30? Now remember what we said about the central limit theorem. You can apply the central limit theorem if the sample size is more than 30, even if the original population is not normally distributed. But if the population is normally distributed, then the sample means are normally distributed as well. So when we were told at the very beginning that the overhead reach distances of adult females are normally distributed, then that meant that the sample size doesn't matter. When we look at the sample means of those adult female overhead reach distances, the sample means are going to be normally distributed because the original population was normally distributed. So we don't have to worry about n being greater than 30 here. So let's see, yes, option C says the normal distribution can be used because the original population has a normal distribution. And that's how we answer that question. See you next time.